Another PicoCTF challenge, and the challenge we're gonna be doing today is gonna be called seed-sPRiNG. So this is not it. I'll put this one right here, and then I'll put my terminal. So with this challenge is called seed-sPRiNG. So it says the most revolutionary game is finally available. seed-sPRiNG is open right now. seed-sPRiNG. Connect to it with this netcat port, and we get 2 hints. How is that program deciding what the height is, and then you and the program should sync up. So if we download seed-sPRiNG, and then if we use one of my favorite decompiling tools called Dogbolt, we could basically insert any kind of binary file or any kind of executable file here. In our case, we're gonna insert it, and then we're gonna get a bunch of variables. But the one that we're gonna focus on is basically this one right here. And the one of the hints it tells us is how is the program deciding what the height is. So if we look right here, we get welcome, the game is easy, you can jump on the spring, how high will you fly, and then it says puts, and then we get sRand, so guess the height. And if local C doesn't equal local 20, then you break local 1C. So local 1C is basically local 1, and it's basically rand. That's basically, so it's just calling random. And then yeah, so it's basically just calling random by itself right here. That's basically how it's deciding it. And if you could look right here too, yeah, same thing right here. Fry seed is equal. Okay, so welcome to how high we fly. Put out that. So it says seed, sRand, and seed. Level 30 puts chunk. So random. So I guess we gotta figure out how does random work. Because scanf is basically our input right here. F4 is our input, and then rand. How does rand work? So rand and C. And if you guys aren't familiar how rand works, it's basically it's used to generate a random number. But in our case, before you call rand, you always want to call random and C. So rand. So in a way, we call these generate the numbers from 0 to n. It's a way to generate numbers, but it's basing it off seed, which is the seed is time 0, which is our current time. So what is this? Just copy this right here. I use this to help me. sRand gives a random function a new seed starting point. Usually random numbers are calculated by taking previous to the seed. It gives a time in unisex, which is pretty good unpredictable seed. You can guarantee you'll see only unless you start with the same. Yeah, I see it says right here. You guarantee your seed will be the same one only once unless you start your program multiple times with the same second. So it's basically if you're able to generate, you're basically able to generate the same outcome of random if you can match up, sync up with the time, and that's what we're basically gonna do. We're gonna write a C++ program or a C program that's basically gonna be the exact same logic and run it at the same time. So nano solve.c, and let's get started. So I'm gonna try to remember seeing what language. Yeah, it has to be in C. So basically, what you want to be able to do is do probably something like, you could probably copy this. Do people you could probably copy this. Oh, it's probably using C++, I guess. We could probably change this to be standard io.h, and then probably time h, which is using the time library. So we could use time and include std lib dot h, and then we can just control K this, and we have this right here. So we'll just do delete K. So following the logic that we found from our source code right here, we could see being ran being generated with get flash time 0 and sran. So you could probably do sran and then probably cover as time 0. So that sets our random variable to always generate according to our time or when we run it. And now what we want to be able to do next is probably something like this. So for every int I is equal to 0, and then we have to do it 30 times according to this logic right here. Yeah, 30 times 30. And I think there's a while loop, yeah, and that is counting it. Maybe I'm assuming this is 30. So hex2 int. Basically, gotta do it 30 times. So I is less than 30, then I plus I is less than 30. And then what we want to do here is basically the logic. So we printf. We're going to print out the values. So it's going to be what percentage D. And then a new line for every one of them. And then what we want to be able to do is generate rand, which is the logic right here. And then we want to AND it with OXF. So AND it with OXF. Now with that, we could basically just return 0. And then we could probably compile this GCC and then solve.c. Wait, didn't I change it? Not there. GCC, and then we'll just run it. And then we're going to want to be able to run it at the same time that this netcat port starts, or once we connect to it. So there should always be a matchup. And then how we do it, how we pass that data over is basically write a pipe. And we got it first try. So when I was doing this challenge, it usually didn't happen the first try. It always took a while. So look, if I try it again, it doesn't work. But it takes a while because I'm assuming you want to do it. And yeah, it works. But eventually it does work. So we get PicoCTF pseudo random, not random generator, not so random. So basically for this challenge, I guess I'll go do a quick overview. The only reason we were able to, I guess, exploit this is because we saw that in the logic, the random number generator was generating based on time, which we could replicate the logic and run and figure out the numbers needed to guess. So yeah, that's about it. Hope you guys learned something today, and I'll see you guys in the next one. Peace.